Let's talk about relays for a minute. What is a relay and what does it do? A relay is an electrical switch that is controlled by one circuit to control a secondary circuit. If you look at the wiring diagram labeled on the relay, you can see different numbers. If you look at 86 and 85, that is one half of the relay, that is one circuit in the relay. It's the control side. With a control circuit, you can send power and ground to that half of the relay to control it, to turn the relay on. It's an electromagnet, so when you send power to it, the magnet becomes active, and it creates a magnetic pull to flip a switch internal to the relay to then control another circuit. So the other half being 30 and 87 and 87A, when you flip that switch with the electromagnet, you're controlling another circuit. So let's look at some of the internals of a relay. So we can see here some of the routing of the wiring inside of the relay. You can see the electromagnet. So when you energize that electromagnet, again, it creates an electrical current that creates a magnetic pull that pulls down on the movable contact on the top. When it does that, there's a contact on the end of it, on the right side there, that goes between the two fixed contacts. So with the electromagnet off, it's contacting one side. With the electromagnet on, it's contacting the other side. So that'll switch between circuits if you need two circuits controlled on or off, or if you're just going from off to on. So to summarize, one circuit controls an electromagnet that then controls the switching of another circuit. If you look at the contacts here, you can see a small gap on the top left there between two contacts. That's all the distance that the relay has to move to make contact. So the electromagnet is not pulling very far, but when it pulls that arm down, making contact between the 2 points on the left. Once those contacts make continuity, when they touch, then you have a closed circuit on the controlled side of the relay. So again, the control side being the electromagnet, creating an electrical and magnetic pull to close the relay, close the contacts, to control a secondary circuit once those contacts are closed. So what then can cause a relay to fail? There's a couple possible causes, and it can fail in different ways. So let's take a look. They can definitely burn up. The contacts get hot. There's a lot of heat going through a relay, so they get hot and they burn up. They arc. You can see the remnants of some burnt pieces of relay in this case from the top of a relay. Somebody took this relay apart, and you can see the chunks of metal that have burnt off from the contacts. We can also take a look at the contact ends themselves and see how they've been burnt. When they are going on and off, every time they touch, they create a small arc, kind of like a welder, but very small. The more that happens and the hotter they get, the more they go on and off, the more that happens, and eventually that heat and that arcing gets worse and worse and creates a poor connection. Poor conductivity creates more heat, and it burns those tips away, and eventually they just stop making contact. They stop making continuity. Maybe they're touching, but they're so corroded and burnt that they're not making any continuity. So the contacts are no good. The electromagnet can also fail. It can become an open circuit, it can become a short, and it can become weak to cause the relay to not be able to switch. So there's a few different ways in which a relay can fail. So to test a relay, there's a couple things you would want to look at. You can first check the control side. You need to make sure that you're getting a power to the relay and that the relay has a good ground. Now this is of course when it should be switched on, so if it's your headlights relay or a fuel pump relay, whatever the circuit is, make sure that it's switched on. Make sure you've got that actually turned on, your key is on, and you should actually have power to it. With that being the case, you can check to see if you've got power and ground to the control side. If you do, and it's not activating, odds are the magnetic side of the relay has an issue. You can also, though, take a battery or jumper leads and put power and ground to the relay and listen for a click, feel for a click. If it's clicking, then you know that that part of the relay is working, and again you need to double check the circuit that you're working with on the car. Now for the switch side, it's a little bit more complicated. You need to know if you're testing for the relay to be open or closed. You need to know what you're looking at, but then you're going to have to activate the relay. So again, whether you do that with jumper leads, a power probe, however you're going to activate the relay, you have to put power and ground to the magnetic side of the relay, and then watch the continuity of the switch side. Does it go from open to closed when you activate the relay, or does it stay open, or does it stay closed? That will tell you what the relay is doing and whether or not it's working. It may also be an intermittent issue, and it's potentially a little bit harder to find. Another way to check it is to take the cover off and look at the internals like the pictures we've seen previously. You can inspect the contact points, you can inspect the electromagnet, look for arcing, heat spots, and wear. If there is excessive heat spotting or arcing on the points, it probably needs replaced. So a visual inspection of the internal components is always a good idea as well. And that pretty well wraps up how a relay works, how they fail, and how to test them. If you have any more questions, leave a comment below.